A physicist sits with a simple calculation. Two clouds of particles tied together by quantum entanglement, the strange link that lets distant things share one state. He turns that link down just to watch. On paper, the space between the two clouds begins to stretch. He turns it down further. The space thins. Then it tears, and the two halves fall into the separate worlds. He was only adjusting the link. The space appeared on its own, and then came apart on its own. That result, sharpened by many hands since, points at something that should not be true. The space you are sitting in may not be the floor of reality. It may be woven link by link from tiny things choosing to share a state. And the weave is still spreading. Where it spreads to is the part no one can explain yet. Reach out and touch the air in front of you. Your hand moves through empty space, and that space feels like the most solid fact there is. It holds everything. The stars sit in it. Your body sits in it. For a long time, physics treated it exactly that way. As the stage every other thing performs on, fixed and given and asked no questions. A growing number of physicists no longer believe that. They think space is not the stage. They think it is one of the performers. Something more basic comes first, and space appears out of it, the way a temperature appears out of trillions of moving atoms with no temperature of their own. That comparison is worth holding. A single atom has no temperature. Heat is not a thing one atom carries. It shows up only when you have a crowd of them, moving and bumping, and the crowd behaves in a way no member does. Temperature is real. You can feel it, measure it, burn your hand on it. But it is not fundamental. It is made of something smaller that knows nothing about heat. The new idea says space works the same way. Not given, not the floor, made. Made of what though? That is the question this whole story chases, and it does not let go. If space is built, then something does the building, and that something cannot itself live in space because space is the thing it produces. It has to be more basic than distance, more basic than here and there. The candidate has a strange name and a stranger nature. Quantum entanglement. We will get to what it is in plain terms soon. For now, hold only this. A link with no length. Between things that do not need to be near each other. Maybe the thread the whole world is sewn from. This is not one lonely physicist with a wild guess. The idea grew out of black holes, out of the mathematics of how information behaves at their edges, and out of a discovery that two completely different descriptions of a universe turned out to be the same universe wearing two faces. People chasing separate problems kept arriving at the same place. Space is not what it seems. Space is woven. And here is the part that turns a clever theory into something colder. If space is woven, the weaving is not finished. It did not happen once at the start and stop. The universe is still getting bigger every second, in every direction at once. New space keeps appearing. If space is a process and not a thing, then the process is running right now, all around you and inside you, and no one can fully say what drives it. So the question splits into two halves that point in opposite directions. What is space actually made of? And why does more of it keep arriving? We are going to follow that question down, layer by layer, into places where our best physics stops working and admits it has no map. Into black holes that grow on the inside while standing still on the outside. Into the first slice of a second after everything began. Into the empty air in this room, which is not empty. Start with the one fact that should already be unsettling. We do not actually know what holds the room together. Drop a pen. It falls because mass bends the space around it. and the pen rolls downhill in that bend. That is gravity. And the description behind it is the best one we have. It comes from Albert Einstein, and it has passed every test thrown at it for over a century. It told us black holes should exist before anyone saw one. It predicted ripples in space from colliding stars, and detectors later caught those ripples passing through the Earth. So this is not a weak theory. It is one of the strongest things humans have ever written down. It breaks in two places, and it does not break a little. It breaks completely. The math collapsing into answers that mean nothing. The first place is the center of a black hole. When a giant star runs out of fuel and falls inward, nothing known can hold it up. It keeps falling. The theory says it shrinks to a single point with no size at all, where the pool becomes endless. Endless is not a number. When the equations spit out infinity, that is the universe handing you a blank page where an answer should be. The theory is telling you, plainly, that it has stopped describing reality here. The second place is the beginning. Run the expanding universe backward, like a film in reverse, and everything rushes together. Galaxies fold back in. Space itself shrinks. Keep rewinding, and you reach a moment where all of it, every star and every stretch of distance, is crushed into that same impossible point. The same infinity, the same blank page, two edges, the smallest, densest thing in the universe, and the first instant of the universe entire. At both, our description of space simply quits. Now here's why that should unsettle you, and not in a small way. A good theory does not just answer questions, it tells you where its own edges are. When Einstein's gravity hits these 2 points and returns infinity, it is not staying silent. It is confessing. It is saying that space and time, as it understands them, are not the deepest layer. Something else takes over down there. Something the theory cannot see. And that something is where the real rules live. For a long time, physicists hoped this was a small repair. A patch. Smooth the point. Fix the infinity. Carry on. That hope has mostly died. The breakdown looks less like a crack in the floor and more like the edge of the floor. Past it, the very idea of a smooth, continuous space may not apply at all. There may be no here and there to speak of. No distance to measure. And if that is true, then the smooth space we live in cannot be the bottom. It has to be sitting on top of something stranger, the way a calm lake sits on top of restless water molecules. The lake looks flat and whole. The molecules know nothing of flatness. They just jostle. And the flatness is what their jostling looks like from far away. The two broken places are our only clear windows onto that deeper thing. They are where the surface wears thin enough to glimpse what lies under it. To look through those windows, we need the thread from before, the link with no length. Because the first real clue to what space is made of did not come from staring into a black hole. It came from two particles quietly sharing a secret across any distance at all. Take two coins, flip them, and each lands its own way, heads or tails, with no say over the other. That is the normal world. Separate things keep their own outcomes. Quantum entanglement breaks that, and it breaks it in a way that took the best minds of the last century years to even accept. You can prepare two particles together so their fates are bound. Send one to the far side of a city or the far side of a galaxy. It does not matter. Measure the one in front of you. The instant you do, the distant one settles into the matching state, locked to yours. Not because a signal raced between them. There is no time for a signal, even at light speed. They were never two separate stories. They were one shared state that happened to be spread across a gap. Hold the strangeness of that. Before you measured, neither particle had a settled answer. Both were genuinely undecided, both possibilities at once. Then one measurement fixes both, together, with no messenger crossing the space between. The link does not weaken with distance. A foot or 1,000 light years, the bond is exactly as tight. This bothered Einstein deeply. He called it spooky action at a distance, and he thought it meant the theory was unfinished, that some hidden gear must be turning underneath to coordinate the two. For decades, it stayed a matter of argument, a thing you could believe or doubt. Then it became a thing you could test. Careful experiments, refined over many years, and honored with the highest prize in physics, closed the loopholes one by one. The verdict is in, and it is not subtle. There is no hidden gear. The link is real. Entangled particles share a single state across space, and the world is stitched together in a way our daily sense flatly denies. This is confirmed. It is not a theory waiting for proof. It is one of the most carefully checked facts we have. Now, sit with what entanglement actually is, stripped down. It is shared information that belongs to no single place. The two particles do not each carry half. The information lives in the relationship between them, in the link itself, not in either end. Pull them apart across the universe and the link stays whole, because the link was never sitting in the space between them to begin with. Read that line again. The link was never sitting in the space between them. That is the crack the whole story climbs through. We are used to thinking distance comes first, and connection second. Things are far apart, so it is hard for them to be linked. Entanglement says the connection does not care about the distance at all. It sits outside it, underneath it, in a place where near and far have not been invented yet. So now you have two pieces on the table, a space that breaks at its edges and confesses it is not fundamental, and a link that ignores space entirely, living somewhere more basic than distance. For a long time, those two facts sat in different drawers of physics. Entanglement was the strange business of the very small, the world of single particles. Space and gravity were the business of the very large, of stars and galaxies, and the shape of the cosmos. Nobody expected them to be the same conversation. Then someone did the obvious cruel experiment, only on paper. Take a space held together by entanglement and start cutting the threads. Watch what the space does. The experiment lived entirely in mathematics, but it was as real as any experiment with glass and wire. A physicist named Mark van Raamsdonk worked through it carefully, and what it showed has not gone away. It has only grown. Start with a stretch of space, described in full by the equations. Inside it, the quantum fields are entangled, every region linked to its neighbors by countless threads of that shared, lengthless connection. This is the normal state. Space, full of entanglement, behaving like space. Now reach into the math and turn one number down. The amount of entanglement between one half of the space and the other. Do not touch the space directly. Only loosen the links across the middle. The space responds. As the entanglement between the two halves drops, the bridge of space connecting them grows thin. The distance across the middle stretches out. The two regions, still described by the same equations, start to feel farther apart, as if something were pulling them in opposite directions. You have not moved anything. You have only weakened the thread, and the geometry is answered by stretching. Turn the entanglement down further. The bridge narrows to a neck. The neck pinches. And at the moment, the last threads across the middle fall to nothing. The space tears clean in two. Where there was one connected region, Now there are two, with no space between them at all. Not a large gap. No gap. The two pieces no longer share a where. They have become separate worlds, each whole, each unaware the other exists. Sit with the order of what just happened. The entanglement did not break because the space pulled apart. The space pulled apart because the entanglement broke. The link was the cause. The geometry was the effect. Loosen the connection and distance grows. Cut it and distance ends. Run that backward and you get the claim the whole field is still circling. Distance is what entanglement looks like from the outside. Two things heavily entangled sit close, two things barely entangled sit far, and two things with no entanglement between them are not far apart at all. They are simply not in the same space. This is a leading idea, not a closed case, and it is worth being honest about that. No one has proven that the room you sit in is woven this way down to the last thread. What has been shown is that in the models clean enough to calculate, space and entanglement rise and fall together, locked, as if they were the same thing seen twice. The link and the length move as one. You cannot change one without the other following. That alone should stop you. We are not talking about entanglement affecting space, the way heat affects metal. We are talking about entanglement being space, the way the metal is its atoms. Take the threads away and there is no space left over, sitting empty. There is nothing. The threads were all there ever was, which raises the question that runs the rest of this story. If space is woven from these links, what is it woven on? What holds the pattern? A weave needs a frame, an edge, a place where the threads tie off. It turns out there may be exactly such an edge. And the most unsettling part is where it sits. Not deep in the center of things. Out at the boundary, on a flat surface, far away, where the whole inside of our world may be nothing but a shadow cast inward. A credit card hologram is a flat sticker. Tilt it and a three-dimensional shape floats up, with depth and roundness that are not really there. All the information sits on the flat surface. The depth is a trick of how that surface is read. Physics took that word, hologram, and aimed it at the universe, not as a poem, as a claim with equations behind it. The claim is this: everything happening inside a region of space, all its depth, all its volume, every event at every point within it, can be fully described by information living only on the surface that surrounds it. The flat boundary holds the whole story. The inside is the hologram. This sounds like a flourish until you see where it came from, because it came from the most careful place in physics, the study of black holes. A black hole hides everything that falls in. By all rights, the more you drop in, the more it should be able to hide. And that hidden amount should grow with the volume inside, the room it has to store things. That is the common sense answer. Bigger inside, more it can hold. It is wrong. The amount a black hole can hold does not grow with its volume. It grows with its surface area. With the size of its edge, not the size of its inside. Pack information into a region of space, more and more, and you do not run out when the inside fills. You run out when the surface fills. The boundary sets the limit. And the boundary is one dimension flatter than the space it wraps. Read that as the universe drawing a hard line. The true amount of stuff a region can contain is set by its outside, not its inside. As if the inside were not the real ledger. As if everything within were really written on the surface, and the depth we see were the reading of that surface, lifted into a dimension that the information itself does not occupy. Then came the result that turned a strange hint into a working tool. A physicist named Juan Maldacena found two complete descriptions of a universe and showed they were the same universe. One description was a space with gravity, with depth and volume, things falling and bending, the kind of place we think we live in. The other was a flat boundary around that space, with no gravity at all, just quantum particles jittering on a surface. No depth. One dimension fewer. They were not similar. They were not roughly alike. They were the same physics, exact, written two ways. Every event in the deep interior had a matching pattern on the flat edge. Ask a question inside, about gravity and curved space, and you could answer it entirely by reading the flat boundary, where there was no gravity and no inside at all. The depth was real to anyone living in it, and also, fully, a way of reading the surface. This is the most studied idea in modern theoretical physics for a reason. It works. It lets physicists translate hard questions about gravity into easier questions on the boundary and back, and the answers come out consistent. It is the firmest ground we have for taking the holographic claim seriously, rather than as a slogan, but it leaves a gap so large it is almost funny. If the real description lives on a flat edge with one less dimension, then the depth, the inside, the direction pointing from the boundary into the room, was never in the flat description at all. So where did that direction come from? Where does the inside grow from, if the surface has no inside? Picture the flat boundary on its own. A surface covered in quantum particles, jittering, linking, sharing states. Flat, no inside, no direction pointing inward, because there is no inward yet. Just the surface and what happens on it. Now the depth has to come from somewhere. The inside of our world, the direction you look when you look into the distance, is not written directly on that surface. It has to be built out of the surface's own behavior. And it is. The way it gets built is the quiet center of this whole idea. The new direction, the one pointing from the boundary into the deep interior, is made of scale, of size, of how zoomed in or zoomed out you're looking at the boundary. Think of it this way. On the flat surface, you can ask about the finest details, the smallest flickers, particle by particle, or you can blur your eyes and ask only about the broad, smooth patterns across large patches. Fine detail at one end, coarse, smeared out behavior at the other. That range from sharpest zoom to broadest blur is not just a way of looking. It becomes a real direction in the interior. Depth. Stand near the boundary, and you are reading the surface at its finest grain, every tiny flicker. Move deep into the interior, away from the edge, and you are reading the same surface but blurred, only its largest, smoothest features left. The journey inward, the act of moving through depth, is the act of zooming out on the boundary. Distance from the edge is the same as scale on the edge. The two are one direction seen two ways. This is not a hand wave. In the working models, the math lines up cleanly. A point deep in the interior corresponds to a broad, low-detail feature of the boundary. A point near the surface corresponds to a fine one. The whole inside, every layer of depth, is the boundary read at every level of zoom at once, stacked into a direction that the boundary itself does not contain. So the extra dimension was never put in by hand. Nobody added a third direction to the flat description. It grew on its own out of something the surface already had. The simple fact that you can look at it coarsely or finely. Scale became space. The range of zoom became the depth of a world. And entanglement is the glue that holds the layers together. The fine flickers near the edge and the broad features deep inside are not separate things. They are linked, level to level, by the same lengthless threads from before. The reason the interior hangs together as one smooth space, rather than falling into disconnected sheets, is that every layer of scale is entangled with the next. Pull those threads, as in the cutting experiment, and the layers come apart, and the depth that was built from them thins and tears. Step back and feel the size of this claim. The depth of your world, the direction you walk, the distance to the wall and the stars beyond it. Maybe nothing more basic than a measure of detail on a faraway surface. Zoom level, dressed as distance. And the only reason it holds its shape is the same quiet link that bound the two coins across a galaxy. This is still the firm part of the story, the part with working math behind it. But to picture how a smooth space gets assembled out of these links, layer by layer, scale by scale, physicists reached for a tool from a completely different world. The world of computers, and the strange diagrams used to keep track of entanglement itself. To track entanglement in a large quantum system, physicists draw it. The picture is called a tensor network. At its simplest, it is a web of dots joined by lines, where each line stands for entanglement between the things it connects. More lines, more shared state. The diagram is a bookkeeping tool built to handle systems too tangled to follow any other way. Then, someone noticed something about the shape of one particular network. The network built to describe the boundary surface, the flat one with its layers of scale, does not come out flat. When you draw it honestly, level by level, fine flickers at the bottom and broad features at the top, it grows a shape. It fills out into the interior. The diagram of the entanglement, drawn for nothing but bookkeeping, has the geometry of the very space it was supposed to be hiding underneath. Walk down through the network. The bottom layer is the boundary at its finest grain, a long row of dots packed tight. Above it sits a sparser layer where groups of fine dots have been bundled into coarser ones, the first step of blurring. Above that, sparser still. Each layer is the surface zoomed out one notch, and the links running between layers are the entanglement tying scale to scale. Stack those layers, and the stack has depth. The depth is the interior. The space was built by the network, rung by rung, out of nothing but links. This is the cutting experiment again, but now you can see the machinery. Each rung of the network adds a layer of the interior, and it adds it by laying down entanglement between that layer and the ones around it. Lay the links, and the layer of space appears. Skip the links, and there is no layer there, just a hole where space should be. The geometry is not drawn first and filled with entanglement. The entanglement is laid first, and the geometry is what the finished pattern looks like. There is a deeper reward hidden in this, and it bears on the broken places from earlier. These networks behave like error-correcting codes, the same kind of trick that lets a scratch disk still play, spreading each piece of information across many spots, so no single scratch can erase it. In the network, the information about any deep interior point is smeared across a wide patch of the boundary. No single point on the surface owns it. Damaged part of the surface and the interior point survives, rebuilt from what remains. That is not a small footnote. It hints at why space is so stable, so smooth, so hard to tear by accident. The world is built like a code that protects itself, every piece of the inside written many times over across the outside. To truly destroy a region of space, you would have to corrupt a wide stretch of the boundary at once. Ordinary bumps and jolts cannot do it. The weave heals around them. So the picture sharpens. Space is a quantum error correcting code, drawn as a layered web of entanglement, growing depth out of scale, holding its shape because every layer guards the next. This is a leading framework, taken seriously by serious people, and still under heavy construction. No one claims the full universe has been derived this way. What they have is the same answer arriving from 3 directions at once: the cut, the hologram, the network, all of them saying space is made of links, and links are made of shared quantum states. If that is right, then distance itself, plain everyday distance, must be a count of those links. So count them. How many threads from here to the wall? There is an actual formula for this, not a metaphor. A clean equation that takes entanglement in and gives geometry out, and it is one of the most important results in the field. 2 physicists, Shinsei Ryu and Tadashi Takayanagi, wrote it down, and it has held up through more than a decade of hard testing. Here is what it says, in plain terms. Take any patch of the boundary surface. Ask how much entanglement ties that patch to the rest of the surface. The answer is written as an area in the interior. The area of the smallest surface you can stretch through the inside to wall that patch off from everything else. More entanglement across the divide, larger that interior surface. Less entanglement, smaller surface. The 2 track each other exactly. You hand the formula a number about shared quantum states on a flat edge, and it hands you back an area, a real piece of geometry in the space within. Entanglement in, surface area out. Sit with how strange and how solid that is at the same time. Area is a thing you measure with a ruler, square feet of it. Entanglement is a thing you measure by how much 2 quantum systems share. These are not supposed to be the same kind of quantity. The formula says they are. It says a wall's area, deep inside the space, is just a tally of how entangled 2 parts of the boundary are. Geometry is entanglement, counted and converted. Run it the way that matters for us. If area is built from entanglement, then so is distance, because distance is just area thinned to a line. Take 2 points in space. The distance between them is set by how the entanglement is arranged in the region around them. Heavily linked, the points sit close. Barely linked, they sit far. The length of the gap is a reading of the threads, nothing more. When you cross a room, you're crossing a certain quantity of entanglement, laid out as floor. This is the rule underneath the cutting experiment from before. Now you can see why turning entanglement down stretched the space and then tore it. The formula demands it. Lower the entanglement between 2 halves, and the interior surface separating them must shrink, which means the bridge between them thins. Take the entanglement to nothing, and the separating surface goes to nothing, and there is no bridge left, no distance, no shared space. The tear was not a surprise. It was the formula keeping its word. And this is firm ground, worth saying plainly. In the clean models, this works. It has been checked from many angles, and it keeps holding. Entanglement and geometry are not loosely related. They are bound by an equation you can write on one line, and the equation says geometry is what entanglement looks like when you measure it as size. So the everyday world starts to read differently. The distance to the far wall is a number of threads. The room you sit in is a pattern of shared quantum states, arranged so that it spreads out into the shape of a room. Empty space, the most ordinary thing there is dense with connection. There is no such thing as truly empty distance. Distance is the connection, which leads somewhere that sounds, at first, like a joke. If every bit of distance is built from entanglement, and entanglement links 2 things across any gap, then every entangled pair would be joined by a tiny thread of geometry of its own. A bridge. And some of the most respected people in physics have said exactly that, out loud, and meant it. A wormhole is a tunnel through space. 2 distant points joined by a shortcut that does not run through the space between them. For most of the last century, it lived in equations and in films, a curiosity allowed by Einstein's gravity but never seen, and easy to file into fantasy. Two of the sharpest physicists alive took it out of that file. Juan Maldacena, the same one behind the holographic result, and Leonard Susskind put forward a claim so blunt, it is usually written as a short string of letters. Entanglement and wormholes are the same thing. Say it slowly. Take any two entangled particles, the kind from the coin story, sharing one state across a gap. The claim is that those two particles are connected by a wormhole, a real one. A bridge of geometry, unimaginably tiny, linking them through the inside of space rather than across its surface. Not a metaphor for their connection. The connection itself, seen as geometry. This grew straight out of the formula from before. If entanglement builds geometry, then a strong entanglement link is a strong piece of geometry. A thread of space running directly between the two ends. For two ordinary particles, that thread is smaller than anything we could ever probe. A wormhole so thin and so short, it can carry nothing through it. But it is there. Every entangled pair in the universe, joined by its own private bridge. And the universe is drowning in entangled pairs. The particles in your hand are entangled with particles in the air, in the chair, in light that left distant stars long ago. By this claim, threads of geometry run from you to all of it. A web of tiny wormholes, far too small to fall into, far too weak to use, stitching everything that has ever touched into one connected fabric. The fabric is space, the stitches are wormholes, the thread is entanglement. 3 names for one thing. Be honest about the standing of this. It is a proposal, not a proven law. It is a leading idea, argued by leading people, and it fits the rest of the picture with a tightness that is hard to ignore. But no one has caught one of these little bridges in the act. What gives it weight is how it dissolves an old problem. Here is the problem it solves. Black holes can be entangled with each other. And when two black holes are entangled, the equations already show a wormhole opening between their interiors. A wide one, a real tunnel joining the two insides. That was known before the claim. The bold step was to say the big wormhole between entangled black holes and the tiny one between entangled particles are the same phenomenon at different sizes. Scale entanglement up, the bridge widens. Scale it down, the bridge shrinks to a thread. One law, running from the smallest pair to the largest. So the strange link from the coin story has quietly become the most physical thing imaginable. Not spooky action with no mechanism. A tunnel. A piece of bent space, joining what looks separated, exactly the way the holographic interior was built from links in the first place. This is the point where the story stops being only about the small and the abstract, and turns towards something you could almost fall into. Because if entanglement opens wormholes, and a black hole is the densest knot of entanglement there is, then the inside of a black hole should be the strangest geometry in the universe. And it is. It does something no one expected. It keeps growing, forever, long after the black hole outside has gone still. From the outside, an old black hole is the most boring object in the cosmos. It sits there. It has a size, set by its mass, and that size barely changes. Watch it for 1,000,000 years, and almost nothing happens at the edge. Still, settled, done. The inside tells a different story, and the gap between the two is one of the deepest puzzles in physics right now. Inside the horizon, along the wormhole-like bridge that the black hole's entanglement holds open, the geometry does not settle. It grows. The interior gets longer. The bridge stretches, more space appearing along it, and it does this steadily, on and on, with no sign of stopping. The outside is frozen. The inside swells. The same object, viewed two ways, doing two completely different things, and both descriptions are correct. Let the strangeness of that land. We are not talking about matter falling in and piling up. We are talking about the space inside the black hole, the room itself, getting larger over time while the door stays exactly the same size. From outside, nothing changes. From inside, the volume runs away, growing past the size of the black hole, past anything the outside dimensions would allow. A room far bigger than the house that holds it, and getting bigger every moment. And it does not stop when you would expect. Everything else about a black hole reaches a quiet end. The outside settles in moments. The temperature, the spin, the surface, all of it reaches a final state and rests. But the interior keeps growing for an absurd stretch of time, far longer than the present age of the universe, far longer than the lifetime of the stars. The outside finished long ago. The inside is still going. This was a shock, because it broke a rule physicists lean on hard. Almost everything in nature reaches a balanced, settled state and stops changing. Heat spreads out and the changes die down. A black hole's outside does exactly that. So the interior should too. It does not. Something inside keeps changing long after every measurable thing on the outside has gone perfectly still. Some clock in there is still ticking, and it ticks for an eternity. That is the puzzle stated bare. There is a quantity that keeps rising inside a black hole, steadily, for longer than the universe has existed. And it is not any of the usual things. Not heat, not energy. Those leveled off ages ago. Whatever is still growing is something else. Something that does not settle. Something with effectively no ceiling. Find that quantity, and you find what time is doing inside a black hole. You find what the growing room is measuring. The size of the interior is the visible face of some hidden count that never stops climbing. And the search for what that count actually is leads straight into one of the boldest ideas in the whole field. Because there is one quantity in physics that behaves exactly like this. One thing that keeps rising long after everything else has settled. That has no natural ceiling. That grows and grows for a length of time, matching the swelling of the room almost perfectly. It's not energy and not heat. It is something closer to how scrambled a system has become. A measure of pure complexity, and it may be the truest clock there is. Shuffle a deck of cards. A few shuffles in, it is still close to where it started, easy to undo. Keep shuffling. The order drifts further and further from any simple arrangement, and walking it back would take more and more steps. The deck is not getting more random in any loose sense. It is getting harder to describe, harder to return to a tidy state. That difficulty has a name: complexity. Quantum complexity is the same notion, made exact. Take a quantum system and ask the plainest possible question. Starting from a simple state, how many small steps would it take to reach the state it is in now? Few steps, low complexity. A vast number of steps, high complexity. It is a count of how far the system has been driven from simple, measured in the smallest moves that can build it. Here is the property that matters. Complexity keeps rising long after everything else has stopped. A system can reach a settled, balanced state, can look completely even on every measurable surface, while its complexity is still climbing underneath, still being driven further from simple with every passing moment. Heat levels off. Complexity does not. It keeps going, for a length of time so long it dwarfs the age of the universe, and only then, unimaginably far out, does it finally top out, match that against the black hole. The interior grows steadily, far past the point where the outside settled, for a stretch of time beyond all the usual clocks, and then, in principle, eventually levels off at a scale no one will ever watch. That is the exact behavior of complexity. The shapes line up, the time scales line up. The leading proposal, pushed hard by Leonard Susskind and others, is that they line up because they are the same thing. The growing volume inside a black hole is its rising complexity made into geometry. The size of the room is a measure of how scrambled the state has become. Read what that does to the inside of a black hole. The swelling space is not filling with stuff. It is filling with difficulty. Every moment, the quantum state of the black hole gets driven a little further from simple, a little harder to undo, and that growing difficulty shows up directly as more room along the interior bridge. Complexity is not described by the geometry. Complexity is the geometry. The clock with no hands is a count of steps away from simple, and the count is what the space is made of. Now push it back out to where we live, carefully, because this is a leading idea and not a settled law. If the size of a black hole's interior is its complexity, then size in general, distance in general, may be telling us how complex a quantum state has become. The growth of space, anywhere, might be complexity climbing. The universe getting bigger might be the universe getting harder to describe, driven further from simple every second, and showing that difficulty as new room. That reframes the whole question of why space grows. Maybe it grows because the quantum state of everything keeps marching away from simple. The way a shuffled deck never wanders back on its own. Maybe expansion is just complexity, written large. It is a startling thought, and it is not the only one on the table, and the honest word is open. But the link between the swelling room and rising complexity was strong enough that people stopped only writing equations about it. They tried to build a piece of it, to run wormhole-like behavior on a real machine and watch. A team set out to test the wormhole idea on a real quantum computer, not to bend actual space, to build a small quantum system that, by the holographic dictionary, should behave like a wormhole, and then send information through it and watch what came out the other side. The setup was delicate. They took a quantum processor, the kind built from superconducting circuits chilled to near absolute zero, and programmed into it a small quantum system tuned to mimic the physics on the boundary, the flat edge side of the holographic story. If the idea holds, then a signal pushed into one part of that system should not just scramble and vanish. It should reappear intact in another part, having traveled the way information travels through a wormhole, rather than across ordinary space. So they pushed a signal in on one side and looked for it to surface on the other. It surfaced. The signal went in, the system did what a wormhole's geometry would do to it, and the information came out the far side in the pattern the wormhole picture predicted. On the processor, the behavior matched. The team had run on a chip, the dynamics that the holographic dictionary translates into a wormhole. The result drew enormous attention, and it deserved attention, because no one had brought these abstract bridges that close to a laboratory before. Then the fight started, and the fight matters as much as the result. Critics pushed back hard, and their point was sharp. Nothing tore open in the lab. No bridge in real space appeared. What ran on the processor was a very small quantum system that shares certain features with the boundary description of a wormhole, and even that was a stripped down, simplified version, trimmed to fit the limited size of the machine. To call it a wormhole, they argued, was to skip over a mile of distance between a tabletop quantum trick and a real tunnel through space. The behavior was wormhole-like in the equations. Whether it was a wormhole in any deeper sense was exactly the thing in dispute. Both sides are partly right, and holding both is the honest position. What the experiment showed, plainly and without dispute, is that a real quantum system can be made to act out the boundary side of the holographic story, and that the gravity side description, the wormhole, predicts what that system does. That is a genuine result. It is the first time the entanglement equals geometry idea reached into a working machine and made a checkable prediction that came true. What the experiment did not show is that space was bent on the bench. No one fell through anything. The leap from a simulated boundary system to a literal bridge in the world is exactly the open question this whole story is built on, and a clever chip did not close it. So the score is mixed, and that mix is the truth of where the field stands. The math keeps working. The translations keep coming out right. Entanglement keeps behaving like geometry, on paper and now on a processor. And yet, no one can point to the moment where the links become the room, where the equations stop being a brilliant dictionary and start being the thing itself. That gap between a working description and a proven reality runs under everything ahead. And it gets wider, not narrower, when we stop looking at black holes and turn to the largest fact about our universe. The thing it is doing right now, everywhere, to all of us. It is growing. Look at a distant galaxy and its light comes in stretched, shifted toward the red end, the way a siren drops in pitch as it speeds away. Nearly every galaxy out there shows this. They are all moving away from us, and the farther one sits, the faster it flees. This is measured, checked, and not in doubt. The universe is expanding, but the picture most people carry is wrong, and the right picture is stranger and more important. The galaxies are not flying apart through space, like debris from an explosion racing outward into a waiting emptiness. That is the easy image, and it misses the point entirely. The galaxies are mostly sitting still. It is the space between them that is growing. New distance is appearing everywhere, all the time, swelling the gaps between things that are not themselves going anywhere. The galaxies ride along as the space they sit in stretches under them. Hold that, because it is the heart of it. Space is not a fixed container that things move around in. Space is the thing that is changing. The amount of it keeps increasing. Take two distant galaxies, mark them, wait, and there is simply more space between them than there was, not because either moved, but because space made more of itself in the gap. The container is growing. The distance is being manufactured. This is why the farther galaxies flee faster. It is not that they were thrown harder. It is that there is more space between us and them, and every stretch of that space is growing. So more growing stretches add up to faster retreat. Double the distance and you double the amount of expanding space in between, and the speed of retreat doubles to match. The pattern is exactly what you get if space everywhere is swelling at the same gentle rate, and that is what we see. Now connect it back. The whole story so far has said space is woven from entanglement, built layer by layer, its distances a count of links. If that is true, then this, the largest fact about our universe, is not a separate phenomenon. It is the weave still being woven. More space means more links, more threads being laid down between things, the fabric thickening everywhere at once. Expansion is the loom still running, and the running has a history we can read. Wind it back, and the expansion was faster long ago. Then it slowed for a stretch as gravity fought to pull things together, and then, against every expectation, it sped back up. We are living in the sped up part. Right now, today, the gaps between distant galaxies are not just growing. They are growing faster than they were, the rate itself climbing. Something is not only making new space, it is making it at an accelerating pace, pressing the universe apart harder over time. That acceleration is the crack where the deepest mystery lives. A universe simply coasting apart from an early push would be strange enough. A universe that slowed, then chose to speed up, needs a cause. Something has to be driving the gaps wider, pouring in new space faster and faster, working against all the gravity of all the matter there is. Whatever that something is, it is the largest source of energy in the cosmos by far, and it is the one we understand the least. It has a name, which makes it sound tamed. The name hides the fact that no one knows what it is. The thing driving the gaps wider has a name: dark energy. The name is almost an apology, because it marks the two things we know and hides how little else there is. It is dark, meaning we cannot see it or catch it, and it carries energy, because it does work, pushing the universe apart. Past that, the honest word is mystery, and it is the largest one in physics. Start with how much of it there is, because the number alone should stop you. Add up everything in the universe, all the stars, all the gas, all the planets and dust, and every glowing thing. Then add the dark matter, the unseen stuff whose gravity holds galaxies together. Together, all of that, everything with mass, everything we can point a telescope at or feel the pull of, comes to less than a third of what the universe contains. The rest, more than 2/3 of everything, is this dark energy. The cosmos is mostly made of the thing we cannot name. The galaxies and stars are the minority. The mystery is the bulk. And here is its defining trait, the one that makes it so strange. Dark energy does not thin out as the universe grows. Everything else does. Stretch space, and the matter in it spreads thinner. The same stuff filling a bigger room. Dark energy refuses. As space grows, dark energy holds the same strength in every stretch, which means the total amount of it goes up as the universe gets bigger. More space, more dark energy, with the same push in every stretch. It is as if expanding the room created more of the very thing that expands the room. Read that loop again, because it is the engine of the runaway. Dark energy makes new space. The new space comes with its own dark energy. That fresh dark energy makes still more space. The thing feeds itself. The more the universe grows, the more grows the force that grows it, which is exactly why the expansion is speeding up rather than fading. A push that scales with the room it is pushing apart can only accelerate. Now lay this beside the woven space picture, and the connection is hard to unsee. If space is entanglement, lay down link by link. Then dark energy looks like the rule that keeps laying it down. The standing tendency of the universe to keep making more fabric, evenly, everywhere, without end. The accelerating gaps of the weave thickening faster. The strange self-feeding nature of dark energy is the weave doing what the complexity story hinted at, marching away from simple, never settling, never running out of new room to add. But naming the engine is not the same as understanding it, and this is where the certainty stops cold. We can measure dark energy with real precision. We can chart how it has pushed the universe apart over its whole history. What we cannot do is say what it is. We do not know what makes it, why it has the exact gentle strength it has, or why that strength refuses to fade. We have measured a mystery to many decimal places and explained it to none. And when physicists tried to calculate from their best theory what the energy of empty space ought to be, the answer they got back was not a little off. It was wrong by more than any prediction in the history of science. off by a margin so vast it reads like a typing error. It is not an error. It is the single largest gap between theory and reality that we have, and it sits at the exact center of why space is growing. When physicists ask their best theory what a patch of empty space should weigh, the theory answers, and the answer is the most wrong number anyone has ever calculated. Not off by a bit, not off by a factor of 10 or 1,000 or 1,000,000, off by a figure with more than 100 zeros after it. Right out the gap between what the math predicts and what we measure, and it runs longer than the number of atoms in your body, longer than the number of stars in every galaxy we can see. This is real, and it has a dry nickname among physicists: the worst prediction in the history of science. Here is where it comes from. Empty space is not supposed to be truly empty by our own best rules. It should carry a baseline energy, a hum that belongs to space itself, even with every particle removed. Physicists can calculate that hum. They add up all the tiny contributions the quantum world says should be there, and they get a value for the energy of nothing. That value is enormous. So enormous that if it were real, it would have ripped the universe apart in its first instant, blown every speck of matter so far from every other speck that no star could ever form. A universe with that much energy in its empty space would be a smear, thin and dead, with nothing in it but distance. We are not in that universe. We are in one with stars, planets, oceans, hands. So the actual energy of empty space, the real dark energy doing the real pushing, is almost nothing by comparison. Tiny, gentle, just strong enough to nudge the gaps wider over billions of years, and no stronger. The theory shouts a colossal number. The sky whispers a faint one. And the two do not differ by a little. They differ by more than any two numbers in physics have ever differed. Sit with what that means, because it is worse than a wrong answer. A wrong answer you can fix. You hunt the error, find it, correct it, move on. This is not behaving like a fixable error. Physicists have stared at it for decades, from every angle, and the gap will not close. The math that gives the giant number is the same math that works everywhere else, that predicts the behavior of particles to more decimal places than any theory in history. That math is not broken. It is our most successful description of reality. And it hands us a number for empty space that is wrong by a margin beyond comprehension. That is the unsettling part. Our best theory of the small and our best theory of the large agree on almost everything except this. Except the weight of nothing. At the exact spot where the question of why space grows lives, the two halves of physics give answers that cannot both be true, and neither side can find its mistake. And notice where this sits in our story. The whole thread has been that space is woven from entanglement, and that dark energy is the weave still being laid down. Now we find that when we try to calculate how much that weaving should cost, how much energy a fresh patch of space should carry, we get an answer that is catastrophically too large. We can build a beautiful picture of space as made of links. We cannot yet explain why making more of it is so nearly free. To even start, you have to look closely at the thing the theory was describing. The empty space itself. Because the reason the theory predicts a roar where we hear a whisper is that, by its own account, empty space is not empty at all. It is crowded. Cool a region of space to the lowest temperature allowed. Pull out every particle, every scrap of light, every trace of matter, until nothing measurable is left. By the rules of the quantum world, that perfect emptiness is still busy. It churns. Pairs of particles flick into being and vanish before they can be caught. borrowing energy for a sliver of time so short the universe never notices the loan. The empty space froths with them, everywhere, always. Physicists call it the quantum vacuum, and the froth is real. You cannot see these flickering pairs directly. They live and die too fast, but they leave fingerprints, and the fingerprints are measured. So this is not a guess. Place two metal plates close together in a vacuum, and they feel a faint push toward each other, coming from nothing but the churning of the empty space around them. The froth outside the plates presses harder than the froth squeezed between them, and the plates drift together. The effect is tiny, and it has been measured in the lab, again and again. Empty space pushes on things. The nothing has a texture. So when the theory tried to weigh empty space and got a monstrous number, this is what it was weighing. All that churning, every flickering pair, across every scale, adding its little jolt of energy to the hum of the vacuum. Add them all up and you get the roar, the prediction too large to survive. The froth is real, the fingerprints are real, and yet the total energy it should carry comes out wrong by all those zeros. We can feel the vacuum pushing on metal plates. We cannot square that with how gently it pushes the universe apart. Bring this back to the woven picture, and it sharpens into something stranger. If space is built from entanglement, then this churning empty space is not a quiet stage with a little jitter on top. It is a dense, living tangle of quantum connection, busy down to the smallest scale, every point linked to its neighbors, the threads of the weave trembling with activity even when nothing sits on them. What we call empty is the bare fabric itself, and the fabric is never still. The froth is the weave, vibrating, and that recasts the whole mystery of dark energy. The question is no longer only why space grows, it is why this churning, crowded, energy-rich emptiness pushes so gently when, by all rights, it should push like a catastrophe. Something holds the roar back. Something cancels almost all of that vacuum energy, leaving only the faint remainder that drives the slow expansion we see. Nearly perfect cancellation, down to more than 100 decimal places, and then a tiny leftover. No one knows what does the cancelling. No one knows why it stops just short of perfect. That leftover, that faint surviving push, is the dark energy stretching the cosmos right now. It is the smallest important number in physics, and it sits on top of one of the largest, and the gap between them is the worst prediction ever made. Hold all of that. The churning vacuum, the gentle push, the woven fabric trembling with connection. Now rewind. Because this same restless emptiness, this froth of flickering quantum pairs, did something at the very beginning that built everything you have ever seen. In the first slice of a second, the froth got stretched, and the stretching wrote the universe. In the first tiny fraction of the first second, the universe did something violent. It grew. Not gently, not at the slow pace we see today, but in a burst so fast and so enormous that the words for it sound made up. In far less time than it takes light to cross an atom, a patch of space smaller than anything swelled to a size beyond imagining, doubling and doubling and doubling again, faster than light could cross it. This is the leading account of the first instant, and it is called inflation. Hold the speed of it. We are taught that nothing outruns light. That rule is about things moving through space. Inflation was not a thing moving through space. It was space itself growing, and space can grow as fast as it likes, because growing is not moving. The gaps did not race outward to anywhere. They simply ballooned, every stretch of them stretching at once, the whole region inflating like a surface blown up past all reason in an instant. There was no center to it and no edge to it. There was just more suddenly everywhere. The reason physicists believe this happened is not faith. It is that inflation solves problems nothing else could, and it leaves marks we can check. Look out at the oldest light in the universe, the faint glow left over from when everything was young, and it is almost perfectly smooth in every direction. The same temperature wherever you point. Smooth like that is hard to explain, unless one tiny patch, all in close contact, got blown up huge, carrying its sameness with it across the whole sky. The smoothness is the fingerprint of inflation, and we have mapped it across the entire heavens. So, the largest theme of this story, that space grows and keeps making more of itself, did not start gently. It started with the most extreme growth there will ever be. The universe began by manufacturing space at a rate that dwarfs anything since, and everything after, all the slow expanding of all the ages, is the calm aftermath of that first impossible burst. And here the woven picture says something quiet and heavy. If space is laid down link by link, then inflation was the loom running at a speed it will never reach again. Weaving fabric faster than light could cross the cloth. Threads multiplying past, counting in a sliver of an instant. The universe did not start as a thing sitting in space. It started by making space, in a flood, and the flood set the stage for all of it. But the burst did more than make room. While it was happening, the churning vacuum from before was still churning, still flickering with its tiny quantum froth. And inflation, growing space so fast, caught that froth and stretched it too. The flickers that should have lived and died unseen got pulled apart, frozen, blown up to enormous size along with the space they sat in. Tiny quantum trembling, magnified into something vast. Those stretched flickers did not fade. They became the faint unevenness in that oldest light. The slight warm spots and cool spots dappled across the young universe, and those slight differences were the seeds. Wherever the froth had been a touch denser, gravity later pulled matter in. Everything you have ever seen grew from those frozen quantum flickers, blown up huge in the first instant, and left as a pattern for gravity to follow. Look up at a galaxy, a spiral of hundreds of billions of stars, and you are looking at a magnified quantum accident. The shape of it, the fact that it formed where it did rather than somewhere else, traces back to a tiny flicker in the vacuum, a random tremble of the empty froth, caught by inflation and stretched to the size of a cosmos. The galaxy is that flicker, grown up. So is the one next to it. So is every structure in the sky. This is the claim, and it holds together with hard evidence. The pattern of warm and cool spots in the oldest light has a particular character, a specific way the bumps are sized and spaced across the sky. Physicists predicted that character from the idea of stretched quantum froth before they measured it in detail. Then they measured it, and it matched. The fingerprints of those magnified flickers are written across the whole sky, and they line up with what tiny quantum trembling, blown up huge, should leave behind. This is as close to confirmed as the early universe gets. Now, walk the chain all the way down to you. The flickers seeded the slight lumps. The lumps pulled in gas by gravity. The gas collapsed into the first stars. Those stars lived and died, and in dying forged the heavier stuff, the carbon and oxygen and iron that did not exist before, and scattered it out. That scattered ash gathered into new stars, new worlds, and one ordinary world gathered enough of it to make oceans and cells, and eventually the atoms that are reading this sentence. Every one of those atoms traces back through that whole chain to a random quantum flicker in the empty froth of the first instant. You are old noise. The matter in your hand began as a tremble in the vacuum, a chance ripple in the churning emptiness, stretched and frozen before the universe was a second old. It was never a special arrangement. It was randomness, magnified and made permanent by the growth of space, and then slowly assembled by gravity over an unthinkable stretch of time into stars and planets and you. The grandest structures in existence and the body you live in are both the same thing at the root. Quantum chance, blown up huge. Feel how this ties the threads together. The churning vacuum that gave us the worst prediction in science is the same vacuum whose flickers became galaxies. The growth of space that we cannot fully explain is the same growth that magnified those flickers into everything. The story does not have separate mysteries sitting in separate rooms. It has one process, space being made, running from the first instant to right now, and it built the structure of the universe out of the tremble of empty space along the way. And it keeps building, because the growth never stopped. The same expanding that stretched the froth into galaxies is the slow expanding still happening today. The gap's still widening, new space still arriving. We are inside a process that made us out of noise and is still running, still laying down fabric in every direction, including the space inside this room. That raises a question we have been circling and can now ask straight. If space is made and information about everything sits woven into it, then how much can the universe actually hold? There is an answer, and it does not sit where you would look for it. It sits out at the very edge of everything we can see. Earlier we met a hard rule about black holes. The amount a region can hold is set not by its inside but by its surface, by the area of the edge that wraps around it. Take that rule and stop applying it to black holes. Apply it to everything, to the whole observable universe at once. Around us, in every direction, there is a kind of edge, not a wall, a horizon. The universe is so large and light moves at a fixed speed that there is a maximum distance we can ever see. Light from beyond it has not had time to reach us since the beginning, and because space keeps expanding, light from far enough out never will. That farthest reach forms a vast sphere with us at the center, the boundary of everything we could possibly observe. It is the largest surface there is. The holographic rule, pushed to this scale, says something staggering. Everything inside that sphere, the entire visible universe, every galaxy and star and atom, and every event that has ever happened within our reach, can be fully described by information written on that far surface. The whole three-dimensional cosmos, all its depth, could be the reading of a pattern on a distant two-dimensional edge. The same trick from the black hole, the same trick from the holographic boundary, but now the region is all of it, and the surface is the horizon of the world. And the rule sets a hard ceiling. The total amount of information the observable universe can contain is fixed by the area of that horizon, and only by its area. Not by its volume, not by how much room is inside, but by the size of the surface around it. There is a largest number of distinguishable things the universe can hold, and it is written on the edge, not packed in the middle. The cosmos has a maximum content, and the boundary sets it. Sit with how strange that is against ordinary sense. You would think a bigger box holds more, and holds it according to how big the inside is. The universe does not work that way at its limit. Double the radius and the volume goes up 8-fold, but the most it can contain goes up only 4-fold, because that follows the surface, not the inside. The deepest accounting of reality is done on the edge. The inside, all the depth we live in, is the lifted reading of that edge, exactly as the holographic story has said from the start. There is one more turn, and it folds the whole thread together. As the universe expands, that horizon grows, the edge gets larger, and a larger edge means a larger ceiling, more information the universe can hold than it could before. The growth of space is not just more room, it is more capacity. The weave thickening, the fabric spreading, is the edge enlarging and the universe's storage going up with it. Space growing is information capacity growing. That word, information, has been pressing at the edges of this whole story, and now it moves to the center. Distance built from entanglement. Geometry equal to shared quantum states. Capacity set by a surface. Every step has been quietly trading the language of stuff for the language of information. So take the trade all the way. Stop measuring reality in feet and start measuring it in bits. A bit is the smallest possible piece of information. A single answer to a single yes or no question. On or off. Here or not here. Everything your phone stores, every picture and message and song, is in the end a vast string of these tiny answers. Ons and offs. Bits. It is the bottom unit of knowing anything. The thread of this whole story has been pulling toward a claim that once sounded absurd and now sounds to many serious physicists like the natural reading of the evidence. Reality, at its base, is made of these bits. Not of tiny balls of matter sitting in space, of information. The particles, the fields, the space itself are all patterns in an underlying ledger of yes and no answers. And the physical world is what that ledger looks like from inside. Trace how the story arrives here, because each step was already taken. Distance turned out to be a count of entanglement. Geometry turned out to equal shared quantum states, an equation with information on one side and area on the other. The capacity of the universe turned out to be set by a surface measured in bits. At every stage, the solid physical thing dissolved into a count of information. Length became a tally. Area became a tally. The universe's total contents became a number of bits on a far edge. The matter kept thinning out and the information kept being what was left. So the recast is this. When you cross a room, you are not moving through a substance called space. You are moving across a stretch of information, a pattern of entanglement, a length of the ledger. The wall is not fundamentally a slab of stuff. It is a dense, stable knot of bits, arranged so that it reads to anything nearby as a hard, flat surface. Your body is a pattern of information too, a particularly intricate one, holding its shape and carrying its memory the way a long, self-correcting message holds its meaning. This is a leading way of reading modern physics, not a finished proof, and the honest word is that it is a frame, a lens that keeps fitting. But it fits with a tightness that is hard to dismiss. Every place we have looked deeply, the physical has reduced to the informational. The holographic result is, at bottom, a statement that the same information can be written two ways, on a boundary or in a depth, and both readings of the world. The wormhole story is, at bottom, a statement that shared information is shared geometry. Strip the pictures away, and what remains, every time, is information and how it is arranged. And here the two halves of the central question begin to merge. We asked what space is made of, and the answer keeps coming back as information, entanglement, bits. We asked why more space keeps arriving, and the complexity story said it might be the quantum state of everything marching further from simple, becoming harder to describe. Both halves are about information, one about how it is arranged into a world, one about how that arrangement keeps growing more involved over time. If the universe is, at its base, information being arranged and rearranged, then a question becomes almost impossible not to ask. Information does not just sit. It gets processed. It gets computed. So a few physicists have asked the obvious, unnerving thing. If reality is made of bits, is something running them? The idea is old, and it is tempting, and it gets misused constantly. So handle it carefully. If the universe is information at its base, then maybe the universe is a kind of computation. Maybe every moment is a step, every interaction a small calculation, the bits of reality being updated according to fixed rules. The cosmos grinding forward like the largest process there is. The thought is clean. It is also where careful physics and loose fantasy sit dangerously close. So the line between them has to be drawn hard. Here is what is solid, and it is more than nothing. The universe does process information, in a plain and measurable sense. Every time two particles interact, the outcome depends on their states, and their states change. That is information being transformed by a rule. Physicists can count how many such basic operations the universe could have carried out since the beginning, given its energy and its age, and the number is finite and enormous. Reality does update itself, step by step, according to fixed laws, and the amount of updating it can do has a hard limit. That much is not speculation. Here is what is open, and it is most of the interesting part. Whether that processing means the universe is a computer in any deeper sense, whether it is running a program, whether there is anything it is computing toward, none of that is established, and some of it may not even be a well-posed question. A rock rolling downhill is following physical law, and you can call that a computation if you like, but it does not make the hill a machine with a purpose. The leap from the universe processes information to the universe is a computer running. Something is exactly the leap. The evidence does not license. It is easy to make in words and impossible to support with data. And the most strained version, the one that says we are inside a simulation, that some outside builder set this running on a machine in a larger world, sits even further out. It is not impossible. No one can rule it out, and that is honestly part of why it spreads. But it explains nothing we could not already explain, predicts nothing we can check, and adds a whole outer world we have no way to reach. As physics, it does no work. It is a story the information picture makes easy to tell, not a finding the information picture supports. So hold the honest shape of it. Reality is informational, and information gets processed, and the universe does update itself by fixed rules, step after step, with a counted limit on how much updating it can do. That is the real result. And it is strange enough. Everything past it, the program, the purpose, the builder, the machine in the larger world, is open at best and empty at worst. And the difference between the two is not yet ours to call. But there is one feature of this stepping forward that we have already met and not yet faced directly. The universe updates in one direction. It does not run backward. The steps go forward, the complexity climbs, the deck shuffles further from order, and never wanders back. That forward-only march has a name we all know, and it may be the deepest clue of all to what is really growing. Time runs one way. You remember the past, and not the future. A cup falls and shatters, and it never leaps back together. Heat flows from hot to cold, and never the other way on its own. Everywhere you look, the world has a direction in time, a difference between forward and back that feels more certain than anything. And yet, here is the quiet scandal at the base of physics. Almost all the deep laws do not have that direction. They work the same forward and backward. Run them in reverse and they break no rule. So the one-wayness of time is not written into the basic laws. It has to come from somewhere else. The standard answer is order. The early universe started in an extraordinarily simple, ordered state, and it has been getting more disordered ever since, And that steady slide from order toward disorder is what we feel as time moving forward. The arrow of time is the universe shuffling, the deck drifting away from its neat beginning and never drifting back. Forward is just the direction of more shuffled. Now lay that beside the thread we have been following, and something lines up that is hard to look away from. We said the inside of a black hole grows because its complexity grows. Its quantum state driven further from simple, step after step, for longer than the age of the universe. We said the expansion of space might be that same climbing complexity, written large. And now the arrow of time turns out to be, at bottom, the same kind of thing. A steady, one-way march away from simple toward more involved, never settling, never reversing. So here is the reframing, offered honestly as a leading idea and not a proven law. Maybe the thing that is really growing is not space exactly, and not time exactly, but the entanglement and complexity of everything climbing together. As the quantum state of the universe gets more entangled, more scrambled, further from its simple beginning, that single rising quantity might show up to us as three things at once. As more space, because distance is built from entanglement. As forward time, because the arrow points the way the shuffling goes. As rising complexity, the deck never returning. One underlying growth, wearing three faces. That would mean space and time are not two separate stages that happen to be expanding and flowing. They would be two readings of the same deepening tangle. The universe is becoming more connected with itself, link by link, and the spreading of that connection is what we call space getting bigger, and the direction of that spreading is what we call time going forward. The growth of the weave and the flow of time would be one event, seen from two angles. This is speculative, and it deserves to be flagged as such, clearly. No one has proven that the arrow of time, the expansion of space, and the rise of complexity are a single thing. What is striking, and what keeps serious physicists circling it, is that all three behave the same way. All three start simple, climb without settling, point one direction, and never reverse. Three of the deepest features of reality, sharing one shape. That might be coincidence. It might be the biggest clue we have. And whatever drives it, it is not far away, out among the galaxies or down inside black holes. The same threads, the same rising tangle, the same one-way climb run straight through the matter you are made of, right now, holding you together. The atoms in your body are entangled, not as a figure of speech, as physics. The electrons in your molecules share states with one another, bound by the same lengthless link from the coin story, and those bonds are part of what holds your chemistry together. The shape of the molecules that make you, the way they grip and fold and react, depends on quantum sharing among their parts. Take entanglement out of the picture and the chemistry of life does not work. The thread the universe is sewn from runs through every cell you have. And it does not stop at your skin. The particles in your body have touched, in one way or another, particles far beyond you. Light from the sun arrives entangled in subtle ways with the matter it left. The air you breathe carries quantum connections to the wider world. Every interaction, every collision leaves a faint thread behind, and your body has been interacting with its surroundings every instant of your life. By the picture this whole story has built, threads of entanglement, and so threads of geometry run from the matter in you out into the room, the planet, the light of distant stars that long ago touched the atoms now in your hand. So, the weave is not somewhere else. You're not a separate thing sitting in woven space, like a stone dropped in a net. You are part of the weave, made of the same threads, knotted into the same fabric as the wall and the air and the sky. The links that build the space around you do not stop at your edge and resume on the other side. They pass through you. You are a particularly dense, particularly intricate region of the same connection that, spread thinner, reads as empty space. Hold that against how solid you feel. Your body seems like the most separate thing there is, a closed unit looking out at a world held at arm's length. The physics says the boundary is softer than that. At the deepest level, there is no clean line where you stop and space begins, because you and the space are made of the same stuff, the same shared quantum states, arranged densely here and loosely there. The difference between your hand and the air it moves through is a difference of pattern in one fabric, not a gap between two kinds of thing. And here the whole abstract story turns personal and a little vertiginous. Everything we followed, the cutting of links that tore space in two, the formula that turns entanglement into area, the tiny wormholes joining every entangled pair, applies to you. If every entangled pair is joined by a thread of geometry, then threads of geometry run from your atoms to the atoms around you, a private web stitching you into the room at the finest scale. The same fabric that spans between galaxies passes through the space between your own cells. This is not mysticism, and it should not be dressed up as a feeling. It is the plain consequence of taking the woven picture seriously and noticing that you are not exempt from it. The threads do not honor the outline of a body. They run through it, the way they run through everything. Which means the test of this whole idea, the experiment that could finally show entanglement and geometry are truly one thing, does not need a black hole or a far horizon. It needs something small enough to sit on a table, and the people building it are closer than you might think. The whole story rests on one bridge that has never been directly crossed. Entanglement builds geometry. Quantum connection makes space. It works in the math. It works on the holographic boundary. It even ran on a quantum chip. But no one has caught gravity itself, the bending of real space, behaving as a quantum thing in front of them. That is the missing piece, and there is now a plan to catch it on a tabletop. Here is the idea, and it is beautifully direct. Gravity is the bending of space by mass. Entanglement is the quantum link that, by this whole story, builds space in the first place. So if you could take two small masses and get them to become entangled through nothing but their gravity, through the tiny pull of one on the other and nothing else, you would have shown something enormous. You would have shown that gravity can create entanglement. And only a quantum thing can create entanglement. A purely ordinary, non-quantum force cannot do it. So if gravity entangles the masses, gravity is quantum, and the bending of space is a quantum process at its root. The experiment is fiendishly hard, and that is why it has not happened yet. You need two objects small enough to behave quantum mechanically, but heavy enough to feel each other's gravity, which is the faintest force there is by an absurd margin. You need to hold them in delicate quantum states, near perfect stillness, shielded from every stray vibration and every speck of stray light, for long enough that their feeble gravitational pull can knit a thread of entanglement between them. The slightest disturbance ruins it. The pull you are trying to detect is so weak, it is almost beneath measuring. But the plans are real, and the teams are serious, and the technology is climbing toward it. Labs around the world are refining the pieces, learning to hold larger objects in quantum states, to cool them harder, to shield them better, closing in on the moment when two masses can be suspended, entangled by gravity alone, and measured. It is not a thought experiment anymore. It is an engineering target, and people expect to reach it. Sit with what hangs on it. For a century, gravity and the quantum world have refused to join. Every other force has a quantum description. Gravity stands apart, described by the smooth bending of space, with no proven quantum nature underneath. This experiment aims straight at that wall. If two masses entangle through their gravity, the wall cracks. Gravity is shown to be quantum, and the central claim of this entire story, that the bending of space and the threads of entanglement are one thing, gets its first direct piece of evidence from the real world rather than from equations. And if the masses do not entangle, that matters too, enormously. It would mean gravity might not be quantum after all. That space might be fundamental in a way this whole picture denies. And the field would have to turn around and rethink from the ground. Either way, a question that has sat purely in theory for generations gets dragged onto a table and forced to answer. So the test is closing in. But suppose it confirms everything. Suppose the weave is real and space is built from links. A question still nags, the most ordinary one of all. If there is an extra direction hidden in the entanglement, woven into the depth of the world, then why can you not see it? Why can you not point at it? Or walk into it? If the depth of space is built out of scale on a distant boundary, woven from layers of entanglement, then there is a real sense in which an extra direction is hiding inside the world. So the obvious question lands. Where is it? Why can you not turn and look at it, the way you turn and look left or right? Why does the world feel like plain three-dimensional room with no secret door? The answer is that the extra direction is not a place. It is not a fourth way to point that you could walk down if only you knew the trick. It is depth in the connections, not depth in the room. The holographic story does not hide a new corridor behind the walls. It says the corridors you already have, the ordinary depth of ordinary space, are the hidden direction. The inside of your world is the extra dimension. You are already standing in it. You have been walking down it your whole life without noticing. Because from inside it just looks like distance. Go back to how it was built. On the flat boundary, the new direction came from scale, from how zoomed in or out you rid the surface. Moving deep into the interior was moving from fine detail to coarse blur. That direction is utterly real to anyone living inside it. It is the depth they walk through, the distance to the horizon. But it does not look like scale to them, and it cannot, because they are inside it. To them, it is just space. The thing that is exotic from the boundary's point of view is ordinary from within. You cannot see the extra direction as extra for the same reason a swimmer cannot see water as strange. It is the medium you are made of and moving through. So the reason you cannot point at the woven dimension is not that it is too small, or too far, or too faint. It is that you are looking for the wrong kind of thing. You expect a hidden direction to be a new place, off to one side, waiting to be entered. But this direction is not off to one side. It is straight ahead, and behind, and all around, the plain depth of the plain world, which only reveals this strange origin when you do the mathematics, and find it was built from links on a surface that has no depth at all. And the weave hides itself for a second reason, the one from the error correcting code. Every piece of the interior is written across a wide patch of the boundary, smeared, redundant, protected. That is exactly what makes space look smooth and solid and seamless, instead of pixelated or threaded. The construction covers its own tracks. A world built from discrete links should, you might think, show its stitching somewhere. Some grain if you look closely enough. It does not, because the code spreads each stitch across so much of the boundary that the seams vanish into smoothness. The weave is invisible because it is woven well. That is why the room around you gives nothing away. The extra direction is the room itself. The threads are hidden by their own redundancy. You live inside the answer and cannot see it, because seeing it would mean stepping outside a fabric you are made of. So accept that the weave is real and hidden and all around. There is one more thing it does that we have not faced. It is still spreading. And if it keeps spreading, the far future of a woven universe is not a small matter. It is the slow thinning of space itself. Follow the expansion forward instead of back. The gaps between galaxies are widening, and the widening is speeding up, driven by that gentle, relentless dark energy making more space in every stretch. Run that forward, far forward, and the story of the universe becomes a story of things drifting apart, faster and faster, with no force able to hold the largest structures together against the growing distance between them. It goes like this, and the physics behind it is fairly firm. Right now, the sky is full of galaxies, billions of them, near enough that their light reaches us. As space keeps expanding faster, the distant ones recede faster, until the space between us and them grows faster than their light can cross it. One by one, over enormous stretches of time, the far galaxies slip past the horizon. Their light stretched and dimmed and finally cut off forever. They do not explode or die. They simply get carried beyond reach by the growth of space and go dark to us and never return. Keep going, and the sky empties. The galaxies beyond our own neighborhood all cross the horizon and vanish. The neighborhood itself, the galaxies bound to us closely enough by gravity, draws together, and the rest is gone. Then, within what remains, the stars burn out, one after another. No new ones forming once the gas runs low. The lights go out, slowly, across a span of time so long it makes the universe's whole history so far look like a single instant. And the expansion keeps on, pressing the dark remains ever further apart. In the deepest future, if dark energy holds its course, space wins completely. Matter is spread so thin, so far, that every particle is effectively alone, separated from every other by distances still growing, in a cold and all but empty dark. The froth of the vacuum still trembles, the weave still spreads, but there is almost nothing left for it to hold apart. The universe does not end in a bang or a crush. It ends in a thinning, an endless dilution, space outpacing everything until everything is alone. And read through the woven picture, this is the loom running to its limit. If space is fabric laid down link by link, then the far future is the fabric stretched past all structure. The threads so spread that no two things can stay knotted together against the widening between them. The weave does not tear here, the way it tore in the cutting experiment. It thins. It keeps making more of itself, gently, forever, until making more of itself is nearly all that is happening, and the cosmos is mostly fresh, empty, expanding space with the old matter lost inside it like dust in a growing dark. This is the most likely long fate, given what we measure, though it leans on dark energies staying exactly as it is, and that we cannot promise. The far future is built on the one number we understand the least. But if that number holds, the end of the story of space is space itself, triumphant and alone, still spreading into a dark that has nothing left to fill. So we have followed the question down as far as it goes, into the first instant and the last, into black holes and horizons and the atoms of your own hand. It is time to return to where we started, and say plainly what all of it points to. We began with a physicist turning down a single link and watching space pull apart. That was the first crack, and we have followed it through every room of this story. Now the answer can be stated plainly, and it is this. Space is not the stage. Space is the performance. It is not a fixed floor that things sit on. It is a process, happening, made of quantum connection and constantly being made more. Walk back through what carried us here, because the answer is the sum of it. Space breaks at the center of black holes and at the beginning of time, confessing it is not the deepest layer. Entanglement, the link with no length, lives somewhere more basic than distance. Turn that link down and space stretches, then tears. The link, the cause, and the geometry, the effect. The holographic results show a whole interior written on a flat edge, its depth grown from scale, its layers held by entanglement. A clean formula turns shared quantum states directly into area. Geometry equal to connection, counted and converted. Every entangled pair joined by a thread of geometry. Black hole interiors swelling with rising complexity. The universe's contents written on its far horizon, measured in bits. Each result a separate road, all of them arriving at the same place. Space is made of links, and the links are made of shared quantum states. So both halves of the question fold into one answer. What is space made of? It is made of entanglement, of information, of the quantum world sharing itself across what we then read as distance. And why does more of it keep arriving? Because the process is still running, the state of everything still climbing away from simple, still becoming more entangled, more complex, more involved with itself. And that climbing shows up to us as new space, as forward time, as a universe getting larger and stranger every second. The growth is not space being pumped into a container. The growth is the deepening of connection, seen as room. This is the payoff, and it has to be held with both hands, the certainty and the open part together. The firm ground is real and hard won. In the clean models, entanglement and geometry are bound by equations that keep holding, checked from many directions, even run on a machine. The leading idea, taken seriously by the most serious people in the field, is that space is woven. The open part is just as real. No one has crossed the final bridge. No one has caught the links becoming the room in the world rather than in the math. The experiment that could show it is still being built. We have a description that works everywhere we test it, and we cannot yet prove the description is the thing itself. But sit with what even the careful version says. The room you are in is not empty, and not fundamental, and not still. It is a dense weave of quantum connection, trembling, spreading, holding its shape because it is built like a code that guards itself. The distance to the wall is a count of threads. The depth of the sky is scale lifted into a direction, and all of it is being made right now, more of it arriving in every gap, the oldest process there is, still running. Space is a verb. It is not where things happen. It is something happening. And it did not finish at the beginning, and it is not finished now. You are not watching this from outside. That is the part to take with you. Everything we followed, the threads building distance, the connection deepening, the weave still spreading, is not a story about the far reaches of the cosmos. It is happening in the space between your own cells, in the atoms of the hand in front of you, in the air a few inches from your face. The entanglement that builds space runs through your body. The threads that read as distance pass through the gap between you and this screen. The same fabric that spans between galaxies, that tore in two when a physicist turned down a link, that swells inside black holes and thins toward the end of time, is the fabric you are knotted into, made of the same shared quantum states, arranged densely enough to be called you. You are not a thing sitting in woven space. You are a place where the weave is dense, and it is moving. The process that made galaxies out of quantum flickers and is still laying down new space in every gap of the cosmos is not paused inside you. The connection that holds your atoms together is part of the same climbing tangle that drives the arrow of time forward and presses the universe wider. The forward of your own moments, this one and this one, is the same forward as the universe deepening. The same one-way march away from simple, that everything rides. You're not separate from the growth. You are a small, intricate piece of it, briefly knotted tight, reading these words while the weave that is you carries on spreading. So the next time you reach out and touch the empty air, remember what your hand is moving through. Not nothing, not a stage, a living fabric of connection, trembling with the same threads that build the stars, being made right now, more of it arriving in the space your hand just crossed. It was never around you. It was always you,